Hello viewers, welcome to National Examinations Council NECO 2022 Past Questions and Detailed Solution General Mathematics Paper 2 Part 2. This part contains questions 6 to 12, about 7 questions, and you are expected to answer 5 questions in this part. Solution to 7 questions in one video. Question 6a. Use logarithm tables to evaluate this problem. Solution. The question can be broken into 3 parts for easy understanding. The first part is without the power and cube root. The second part is to apply power operation on the first part, and the third part is to apply root operation on the second part. Let us put all of these together to get the solution. The solution continue. This is the first part. We consider the numerator. The first number there is 565. When you are to get the logarithm of a number, you do two things. You get the characteristic or integer part and the multiplier or whole number or decimal part. Multiplier or decimal part. To get the integer part or characteristic part, you subtract 1 from the number of digits in the whole number part. We have 3 digits. If you subtract 1 or you write this number in standard form, the power to base 10 is going to be 2. Or if you subtract 1, you are still going to have 2 as the characteristic. Then followed by decimal point. Next thing is to get the multiplier. To get the multiplier, you strictly use the logarithm table where you check 56 under 5, no difference. The operation of the logarithm table is to 4 digits, whereby you take the first 2 digits from the left under the third, difference the fourth. Since there is no fourth digit here, we consider 56 under 5, and that is 7520. The next number is less than 1. To get the integer part easily, you write the number in standard form. If you do that, the power to base 2 is the integer part, and that power is -2, written as bar 2. For the multiplier, you check 53 under 6. You have 7292. Multiplication implies addition of log values. If you add these two results, you have this result. Let us take it forward. The denominator is this. The integer part is 2. If you subtract 1 from the 3 digits in the whole number part. For the multiplier, you check 24 under 9, difference 1. That is 3964. Let us take it under the first result. Division implies subtraction of log values. So if you subtract these two results, you have this for the whole of part 1. Part 2 is power operation, and the power is 2. Power operation implies multiplication of the log values. So you multiply this result by 2. Starting from the right to left, you have this result. The next step is root operation. You carry out root operation on part 2. What you are dealing with now is the result. So cube root means you divide the result from part 2 by 3. Now, you cannot divide by 2 by 3 easily. Here, we try to ensure that when we divide, our answer is a whole number, not decimal. So, you transform by 2 to by 3 plus 1 so that 3 can divide by 3. You see how or why we have to write by 2 as by 3 plus 1. You must know that anything you are transforming into, if you reverse it, you get the original 10. Now we divide. By 3, divide by 3, you have by 1. Now if you divide 1 by 3, is 0 remainder 1. If you add that 0 to by 1, you still have by 1, then decimal point. You take remainder 1 to 1, it becomes 11. Divide by 3, you have 3 remainder 2. Remainder 2, you take it to 6, it becomes 26. Divide by 2, you have 8 remainder 2. Remainder 2, take it to 9, it becomes 29. Divide by 3, you have 9 remainder 2. Remainder 2, take it to 6, it becomes 26. Divide by 3, you have 8 remainder 2. No other digits. If you wish to continue, because of the decimal point, you can add 0 to remainder 2, it becomes 20. Divide by 3, you also have 6, and so on. Next thing is to check the antilog of this result. In the antilog, we are interested in the decimal part only. So you take 0.38 under 9 difference 8. That will give 2454. Next thing, this integer part of by 1 simply means you should have 1 0 to the left. 1 0 to the left. So you have 0. Then the point comes after the first 0. So you have 0.2454. Now, assuming this one is positive, you need to add 1 to it. Why? Because you subtracted from here to get these 2. So assuming by 1 is plus 1, you need to add 1 and you move. That means it will be 2. So you have to move 2 steps forward from behind. But because it is by 1, it implies 1 0 to the left. If you have by 2, it implies 2 zeros to the left, and so on. So the final result is 0.2454. Question 6b. An arc AB subtends an angle of 300, an angle of 36 degrees at the center of a circle of radius 7 cm. Calculate the area of the minor sector. This diagram illustrates the information. All we have, the angle precisely is in the minor sector, so no other operation is needed. But assuming you are asked to get the area of the major sector, you need to subtract the given angle that is in the minor sector from 360 degrees. But since we have it in the minor sector, we work with it the way it is. Area of minor sector, the formula is this. You replace theta with 36 degrees over 360 degrees times pi times 7 square. That is the radius. If you simplify this, you have 1 over 10. 7 squared is 49. Divide by 7. 7 is remaining. And of course, you have 22 in that place. If you multiply and divide, you have 15.46 square centimeters as the area of the minor sector. Question 7a. Given the arithmetic progression AP, you have 6, 9, 12, 15, 18, and so on. Find 8. Roman figure 1, 99th term. Roman figure 2, nth term. Solution. From the given AP, the first term A is 6. The common difference is 3 because you subtract either the second and first term, or third and second term, or fourth and third term, and so on. Whichever one you choose to carry out, you will have 3. At the 99th term, n is equal to 99. So you record the nth term. Already we know all the various parameters. So you have t sub 99 is equal to first term A plus n 99 minus 1 in bracket times 3. You have 6 plus 98 times 3. You multiply before you add. So you have 6 plus 2, 94. That is 300. Roman figure 2, you are asked to find the nth term. That means t sub n. You replace first term with 6. N is equal to n minus 1 in bracket times 3. If you open the bracket with 3, you have 6 plus 3n minus 3. Now 6 minus 3 is 3 plus 3n. If you factor out 3, you have 3 bracket open, 1 plus n bracket close. Question 7b. Differentiate y equal to square root of bracket open 1 minus s cube bracket close with respect to s. Functions like this are differentiated using chain rule. So the chain rule is stated in this form: dy ds equal to dy du times du ds. You can see the chain, the variable linking both sides together. This is the given function. Now let's convert the roots to power of 1 over 3. So the term you have inside the bracket is u. So let u equal to 1 minus s cube, so that y is equal to u to the power of 1 over 2. You replace this term with u. So we get du ds. Differentiate u with respect to s. Differentiate 1 is 0 because it's a constant. If you differentiate minus s cube using power rule of differentiation, you have minus 3s squared. Then differentiate y with respect to u, that is dy du. If you use the same rule, you have 1 over 2u to the power of minus half. If you take this term down, the power becomes positive in this form. Now back to the rule. Dy ds is equal to dy du, which is this times du ds. If you multiply this term by 1, you have minus 3s squared. Now over this term, which is this. But what is u? 1 minus s cube. So you replace u with what it stands for. So you have 2 bracket open, 1 minus s cube bracket close to the power of 1 over 2. This power means square roots. You can express your final result using square root, or you leave it in this form. If you express this power as square roots, you have these results. For differentiating the given function with respect to s using chain rule. Question 7c. A curve passes through the point -3, 5 and its gradient at any point is given by 6s squared plus 10s minus 7 full stop. Find the equation of the curve. Solution. The gradient m is the same as dy dx, that is the change in y with respect to s. In other words, dy dx is equal to the given function. The curve means you should get y, so multiply through by ds to clear fraction. To get y from d, which is differentiation, you need to integrate both sides. So you have integral dy equal to integral of the function in the right hand side. If you integrate dy, you have y. Using the integration rule for algebraic function, which is integral s power n ds to be equal to s power n plus 1 over n plus 1 plus c. So when integrating, you simply add 1 to the existing power and divide by the sum of the powers. So this becomes 6s cubed over 3. The power here is 1. If you add 1, it becomes 2. So you have plus 10s squared over 2. This is a constant. If you integrate a constant, it simply attracts the variable you are working with. That is minus 7s plus c, the constant of integration. Anytime you are dealing with indefinite integral, the constant of integration is always included. If you divide through, or if you divide 6 by 3, divide 10 by 2, you have y to be equal to 2s cubed plus 5s squared minus 7s plus c. You need to get c, so you use the point that the curve passes through. So at that point, s is minus 3 and y is 5. You replace them in this result and you have this. If you simplify, you have this and you have this and you have this and you have this. It is step by step simplification. To get c, you transfer 12 to the left hand side and you have 5 minus 12 equal to c. Therefore, c is equal to minus 7. The curve is y equal to 2s cubed plus 5s squared minus 7s plus c, which is now minus 7. So you have minus 7. Alternatively, if you want to get the curve, you can use this simple rule. That is y equal to integral of the gradient function, then followed by ds. Question 8a. If s and y are surface area and volume of a sphere respectively, and s over y is equal to 2 over 7, find the values of s and y. Solution. To find the surface area s and the volume y of a sphere, the radius is needed. So you have surface area s, the formula is this, volume y, the formula is this. But From this expression, which is this, if you cross multiply to clear fractions, you have 7s equal to 2y. So you have 7 times the surface area formula equal to 2 times the volumes formula. If you open the bracket, you have this result. You can divide through by pi arrow square. If you do that, you are left with this. To get arrow, you can multiply through by 3 to clear fraction and divide by 8. So arrow is equal to 28 times 3 divided by 8, and that is 10.5 centimeters. It follows that S is equal to 4 pi arrow squared. So 4 times 22 over 7 times 10.5 square. That is the radius. You simplify, you get this, and you get this. When you divide, you have 1,386 square centimeters. Y is the volume with this formula. This is 4 over 3 times pi times radius cube. That is 10.5 cube. If you simplify, you get this result. If you multiply, you get this result. And when you divide, you have 4,851 cube centimeters as the values of S and Y. Question 8b. Find the equation and the s-intercept of a line which is perpendicular to the line 3s plus 3y equal to 5 and passes through the point 3, 2. Solution. Let the equation of the line required be y equal to ms plus c, where m is the gradient. From the given equation, you need to get the gradient of the given line. So you transform the given line to this form by simply solving for y, and that gives this. Now m, the gradient, is the coefficient of s. So m1 for the first line is equal to -1. Now, if two lines are perpendicular, the product of their gradients is equal to -1, not this -1. This -1 is the gradient of the given line. But if two lines are perpendicular, the product of their gradients is equal to -1. This will help us to find the gradient of the second line. We have already assumed that line to be this with gradient m2. What it means that to get m2, if you multiply m1 by m2, the product is equal to -1 because the two lines are perpendicular. So this is what you have here. We are interested in m2, so divide through by m1. You have this result. Now m1 is -1. If you divide -1 by -1, you have +1. So since the line passes through the point 3, 2, we get C as well. We get C as well. Now the line we have already now is y equal to ms plus c. Now m is 1. From this point, s is 3 and y is 2. You have it in this form so that you can get c. So you have 2 minus 3 equal to c, and c is equal to -1. Hence, the equation of the required line is y equal to ms plus c. Now m is 1, so you have s. Y equal to s C is minus 1. So you have y equal to s minus 1 or y minus s plus 1. If you move everything to one side, equal to 0. Next thing is to get the s-intercept. For the s-intercept, you ensure that you make s the subject in this case. If you make s the subject, you have s equal to y plus 1, so that the s-intercept is 1. The s-intercept is 1. Now, if you have the equation in this form, y-intercept is minus 1. Now that you have it in this form, s-intercept becomes 1. So to get s-intercept, s becomes the dependent variable that stands alone. So the other term becomes s-intercept, that is 1. Question 9a. Make m the subject of the formula. This is the formula. Hence, evaluate m if n is equal to 3, f is equal to 4, d is equal to 8. In the given formula, what to do first is to remove the square root sign, and that is possible if you square both sides. So m becomes m squared. The square removes square root from here. You have it in this form. You need to clear the fraction, multiply through by d minus n. You have it in this form. Now, we have m squared here, and we have minus m squared f. So you have to collect like terms. So this term is already here. You transfer this term, it becomes plus m squared f equal to n plus 1. If you factor out m squared from this place, you have m squared here, d minus n plus f in this form. To get m squared, divide both sides by d minus n plus f, so m squared is equal to this. And to get m from m squared, you need to take the square root of both sides. So you have this result. When n equal to 3, f equal to 4, d equal to 8, m is equal to square root of 3 plus 1 over 8 minus 3 plus 4. That is square root of 4 over 9, and you have 2 over 3. Question 9b. If arrow varies inversely as the cube of s and arrow is equal to 8 when s equal to 4, find s when arrow is equal to 512 over 216. Arrow varies inversely as the cube of s is this. In variation, we usually do away with the symbol of variation by introducing equality sign and the constant of variation to multiply the right hand side in this form. When arrow equal to 8, s equal to 4, this is to enable you find k. So you replace arrow with 8, s with 4 in this form. If you multiply through by 4 cube, which is 64, that clears fraction. So you have 8 times 64 equal to k, or k equal to 8 times 64. That is 512. You need to state the formula connecting arrow and s. You simply come here and you replace k with 512 in this form. This also means that arrow s cube is equal to 512. You are now asked to find s when arrow is equal to 512 over 216. So let's recall this formula and simply make s cube the subject by dividing through by arrow in this form. So you have 512 over 1. Because arrow is fractional, let us use division sign. So you have 512 over 1 divided by 512 over 216. In division of fractions, division sign changes to multiplication and you invert the fraction at the right side. So you have this result. 512 cancel 512. Divide 216 by 1, you have 216. To get s from s cube, you need to take the cube root of 216, and that is 6. Therefore, s is equal to 6 when arrow is equal to 512 over 216. Question 9c. Find the derivative of y equal to cube root of s to the power of 4 with respect to s. This is a single function and you use the power rule of differentiation, which states that if y is equal to s power n, then dy ds is equal to n times s to the power of n minus 1. This is the given function. You need to express it in this form. So you need to convert cube roots to the power of 1 over 3 in this form. And when you evaluate the two powers using power law of indices, you have s to the power of 4 over 3. Then you differentiate. The process of differentiating means you will obtain the derivative of that function. So n is 4 over 3. You bring it to multiply s, then the power minus 1. You have it in this form. So you have 4 over 3. S power 1 over 3 can also be expressed as cube root of s. So you have it in this form. Question 10. A composite solid consists of a cone on top of a cylinder. The cone is 8 cm high and its slant height is 10 cm. If the solid is 18 cm high, calculate the volume of the solid correct to two significant figures. The volume of the solid is simply the volume of cone plus volume of cylinder. The diagram illustrates the information. This is the slant height of the cone. This is the height of the cone as well. Now, y is here 10. The height of the whole solid is 18 cm, and from here to here is 8. So the remaining height is for the cylinder, and that is 18 minus 8 equal to 10 cm. The solution continue. Volume of solid, as I said earlier, is volume of cone plus volume of cylinder. You have it in this form. The base radius is needed in both cases, but easily obtained considering the right circular cone because the slant height, the height and the radius are connected by Pythagoras rule in this form. So you have square of the slant height equal to square of the height, that is 10 square equal to 8 square plus arrow square. You have 100 minus 64 equal to arrow squared. Arrow squared is equal to 36 and arrow is the square root of 36 and that is 6 centimeters. So let's get the various parts. Volume of cone, the formula is this. So 1 over 3 times pi 22 over 7 times arrow squared, that is 6 squared times the height 8. If you simplify further, you get this result. After multiplication, you get this, and after division, you have 301.7143. Next is the volume of cylinder, and that is pi arrow squared h. You have 22 over 7 times 6 squared times 10. That simplifies to this. Therefore, volume of the solid is the addition of the two volumes, and you have 1433.143 to 2SF. You have 1400 cube centimeters. Question 11a. Copy and complete the table of values below for the relation y equal to 6 plus 3s minus 3s cube. You have the table of values with some missing y values and you are expected to solve for them. Be part of the question. Draw the graph of the relation this using a scale of 2 cm to 1 unit on x-axis and 2 cm to 5 units on y-axis. See part of the question. Using the same scales and axes, draw the graph of y equal to 2 minus s. So we have 2 in 1, quadratic graph and linear graph in the same graph notes. The part of the question. From your graphs, determine the Roman figure 1 maximum value of y and the corresponding value of s for which this occurs. Roman figure 2, solution of the equation 6 plus 3s minus 3s squared equal to 2 minus s. That is the points of intersection of the curve and the line traced to x-axis give the solution to the equation. Solution A part, table of values for the quadratic function. Already s values are known. To get y values, we need to do two things precisely. Get 3s and minus 3s squared. Going by the order of the equation, you meet 6 first. 6 is a constant, and as such, you write it under each value of s. So you have 6, 6, 6, and so on. Next thing is to get 3s. To get 3s, you simply multiply each value of s by 3. So minus 3 times 3, you have minus 6. 0 times 3, you have 0. 4 times 3, you have 12. Next thing is to get minus 3s squared. You need to get s squared first, and you multiply that result by minus 3. So minus 3 squared is 9 times minus 3. you have minus 27. Minus 2 squared is 4 times minus 3, you have minus 12. Now 4 squared is 16 times minus 3, you have minus 48. If you add down, you have minus 30, here is minus 12, and so on. Now, let us also construct the table of values for the linear equation so that we can plot directly. So this is the linear equation. We are using the same range of values for s. Now, in that equation, 2 is a constant. You write it under each value of s. Now, to get minus s, you simply multiply each value of s by minus 1. So, minus 1 times minus 3, you have 3. Minus 1 times minus 2, you have 2. Minus 1 times 1, you have 1. And so on. To get y, you add. So you have 5. If you add, you have 4. You have 3. You have 2. You have 1. Here is 0 minus 1 minus 2. Next thing is to plot the two graphs. Back to B part of the question, the given scale, you have 2 cm to 1 unit on x-axis, 2 cm to 5 units on y-axis, This scale implies that one line is 0.1 units on x-axis and 0.5 units on y-axis. Okay, now this graph I'm using, you can see that each box contains 5 lines. So by default, the one box you are seeing now is 1 cm. So what the scale implies on x-axis, you combine two boxes from the origin, you give it 1. The next one is 2. The next one is 3. If you move to the left, you have minus 1, minus 2, minus 3. Then on the y-axis, you combine two boxes and you give it 5. The next two boxes, 10. If you move down from the origin, you have minus 5, minus 10, minus 15, and so on. Now, why is the x-axis close to the top? It is because if you check the values of y, you have minus 30, and the positive just 6, from let's say from 1 to 6. So in drawing your x-axis, you need to give a better space or much space to the negative values of y. So you draw the x-axis closer to the top. Now, if you take it at the middle, it might not accommodate minus 30. Hence, the trick of shifting it up so that you give more space to the negative y values. Next thing is to plot when s is minus 3, y is minus 30. This is the point of intersection of the 2 points, minus 2, minus 12. Now, we said that on the y-axis, one line is 0.5. In other words, 2 lines will give you 1. 2 lines will give you 1. So after 10, the next 2 line 11, the next 2 line minus 12, somewhere here. So this is minus 2, minus 12. Minus 1, 0. When y is 0, s is minus 1. You plot that point directly on the s-axis, then 0, 6. So when s is 0, y is 6. So after 6, after 5, the next 2 lines becomes 6. When s is 1, y is 6. So this is the same 6 against 1. When s is 2, y is 0. you plot that point directly on the x-axis. When s is 3, y is minus 12. This is the point of intersection. When s is 4, y is minus 30. Next thing is to join the points together before you plot the linear graph. Don't forget the title of the graph. It is simply the equation that you are plotting. You can see that all the points have been joined together for the quadratic curve. Next thing is to plot the linear equation. You have the table of values as this. So minus 3 for s is against 5 for y. Minus 2 and 4. Minus 1 and 3. 0, 2, 1, 1, 2, 0. Then 3 minus 1, 4 minus 2. Very close points. Next thing is to join the points together. Because it is a linear graph, you're supposed to have a straight line graph. All the points have been joined together for the linear graph, and the title of the graph updated to reflect both the quadratic and the linear graph. We move to the part of the question. The part of the question, Roman figure 1, maximum value of y and the corresponding value of s for which this occurs. Now, the peak of the curve is the maximum value of y. If you trace to y-axis, you have 6.5. From that point, if you trace it to the s-axis, you have 0.5. Noting that on the s-axis, one line is 0.1. So if you count from the origin to that point, you have 0.5. And on the y-axis, one line is 0.5. So if you count from where you have it there, you have 6.5. Now, Roman figure 2, solution of the equation. The solution is the point of intersection of the curve and the line. The points of, because there are two points of intersection of the curve and the line. This is the first point of intersection. This is the second point of intersection. If you trace this point to the s-axis, it is between minus 0.6 and minus 0.7. So in between becomes minus 0.65 or 2. This point is very easy to get. So that's the solution of this equation. The curve and the line. Question 12. The pie chart below shows the sectorial allocation of subjects offered by 720 students in a college. Roman figure 1. Determine the values of s and y. Roman figure 2. What percentage of the students offered maths correct to 1 decimal place? Roman figure 3. If a student is picked at random, find the probability that the student offer either economics or civic education. Solution. A critical look at the pie chart shows that this angle is 90 degrees. So you write this and equate it to 90 degrees. If you open the bracket, you have 4s plus 3y equal to 90. You call that equation 1. Again, if you add all the angles in the circle, the sum is equal to 360 degrees. If you open the brackets, you have this result. If you add like terms, you have this result. Divide through by 6, you have 2s plus 3y equal to 60. That is equation 2. Solve both equations simultaneously using elimination method. Now, we can eliminate variable y because its coefficients are the same in both equations. So you need to subtract equation 1 and 2 in order to eliminate y. If you do that, you have 4s minus 2s equal to 2s. Then plus 3y minus plus 3y is 0. 90 minus 60, you have 30. To get s, divide both sides by 2, and s is equal to 30 over 2, and you have 15. Let us solve for y and continue. Substitute s equal to 15 into equation 2 to get y. This is equation 2. You replace s with 15 and you have 30 plus 3y equal to 60. You made 3y the subject and is equal to 60 minus 30. 3y is equal to 30. Divide through by 3 to get y, and y is equal to 10. Therefore, the values of s and y are 15 and 10 respectively. Roman figure 2, percentage of students who offered mathematics, that is sectorial angle. Sectorial angle for students who offered mathematics over total angles times 100%. So you have to replace s with 15 and y with 10 in this form over 300. And okay, from here we've already reduced 0, removes 0, so here is 36, then 10%. If you simplify the numerator, you have 45 plus 50 over 36 times 10%. That simplifies to this. If you multiply and divide, you have 26.4%. Roman figure 3, probability either a coins or civic education is the addition of the two subjects. Now let us get those who offered a coins. Their sectorial angle is 90 degrees over 360 degrees times total number of students 720. If you simplify, you get this, and 180 students offered a coins. Number of students who offered civic education is equal to sectorial angle for civic edu, that is 10y degrees over total angles in the circle times total students. That simplifies to 10 times 10. Previously y is 10. So 10 times 10 over 360 times 720. That simplifies to this, and you have 200 students. So the required probability is equal to those that offered economics plus those that offer civic over total students. You have 380 over 720. That simplifies to 38 over 72, and you have 19 over 36 as the required probability.